Hi, my name is Abby Stanlick. I'm a junior in the Materials Engineering Department, and I'm the student president of Reform. So Reform stands for Recyclables for Music. Basically what we do is we take waste plastics and we recycle them into 3D printer filament, which we use to print musical instruments and musical instrument accessories. So Reform has had a lot of success in its 2 years on campus. So we've won several awards on campus, including the Student Innovation Fund, and we are celebrating our first official year as a student organization this year. So let me walk you through our process. The recycling process starts at collection. This will be handled by our recycling team. So we collect both PLA and PET around campus. So we collect PLA in labs that have 3D printers and student orgs that also use 3D printers. We collect PET in these bins all around campus that are marked for number 1 plastic, water bottles only. So PET is typically used to make water bottles or other food packaging. PLA is really commonly used for 3D printing. So PLA is where we started our 3D printing journey. The next step in the recycling process is sorting. So once we get all of our plastics, we sort them by color to make sure we don't have any contamination, and we sort them by plastic type to make sure everything we're getting in these bins around campus is truly PET. Next, we remove the caps because they're different colors and they're often different plastics, and we remove all of the labels from our plastic. The next step in the recycling process is cleaning. So currently we clean everything by hand. We have to cut it into pieces and clean. After that, our plastic is ready for grinding. So we'll take our plastics, grind them up into small pieces, grind them into even smaller pieces, and then they're ready for extrusion. The extrusion process requires really specific parameters. It takes us a lot of experimentation to figure out what parameters we use for each new type of plastic and each new color of plastic, because every plastic is a little different. For PLA, we can use lower temperatures. For PET, we have to use higher temperatures. The extrusion process starts with us dumping our ground up plastics into the hopper. We have several different heating zones along the way as the plastic melts, and at the end, we get a usable 3D printer filament, something like this. So that covers everything that our recycling team is responsible for. Our second team that we like to talk about is our process team. So our process team handles the design, building, and maintenance of all of our machinery. So any of our 3D printers, the process team is in charge of helping maintain and helping set up all of the settings that we need. Currently, the process team is working on a new way for us to make strips and grind up our water bottles more efficiently and more effectively than our traditional grinder. The final team we have is the music and outreach team. They're in charge of everything from 3D modeling our instruments all the way through the actual printing. So they will model instruments, print them out, test them for ease of use and for how they sound, and then go back to the drawing board and make adjustments as needed. Music and outreach team is also responsible for getting out the word about Reform. So they will work on outreach with local schools and around campus to try and get our name spread. Some of the big challenges that Reform faces is being the first people to try and do something. So recycling PLA is something that you'll see on YouTube, people trying to do in their garage, but trying to get really high quality filament and trying to get consistent results was a big challenge for us. So one of our main ways that we're trying to tackle that is making sure we're tracking all of our processing parameters and making sure that we have the best equipment possible. So we, as you'll see in later videos, we have the EX6 extruder, which will be really great for helping us really finely tune our temperature control throughout the extrusion process. Additionally, PET is a really finicky plastic, so it's a lot harder to work with than PLA, where we started. And so trying to make sure that we take our PLA process and we edit it and tweak it as needed to work for PET. So that'll mean higher temperatures, potentially longer time melting, and different cleaning processes as we have completely different products that are coming in for our raw material. So a standard water bottle can have up to as many as 7 different types of plastic between the lid, seals, the bottle itself, the label, and adhesives. So all of these plastics are going to have different properties where they'll melt at different temperatures, some of them won't melt, they'll burn. So when we go through this extrusion process, we really want to make sure that we have the one type of plastic that we think we're recycling. So we try to make sure that we get all of the labels, all of the adhesives, and separate the caps off of our water bottles so that we know when we're running into issues, it's a PET issue and not a contamination issue. As things come in from collection, there's usually a lot of leftovers in the bottles. So the cleaning process is also really important to make sure that our product at the end is pure. One of the other major challenges that Reform faces is with our musical instruments. So safety is a huge concern, and so is instrument quality. So making sure that we're printing things that are safe to use in many different settings and things that produce the sounds that we want them to produce. It's a huge challenge. And so what we've been trying to do with that is mostly a test and record method. We can print something, test it, record the results, and then make changes down the road to try and improve those properties. If we're seeing issues in acoustic properties or in usability, we can tweak our design, try it again. So let me show you a couple examples of what we can make with our recycled filament. So the first musical instrument we ever printed was this ocarina made from 100% recycled PLA. It sounds okay, and we are working on the development of this instrument further. The second instrument that we've made is made out of PET. This is called a Zune. It's an egg flute, and its acoustic properties aren't as good as the PLA, and we're still looking to improve those properties with PET. The really cool thing about this instrument is that we were able to take it from raw water bottles to an actual usable instrument. So we are very proud of the progress that we made. We were able to do this within about a semester's of trial and error. This is not our final product, and we know we can improve much further from where we start here. The most exciting part about Reform is getting to work with people from different backgrounds. We work with people from materials engineering, mechanical engineering, all the way up to music, sustainability, and statistics, and everywhere in between. So we get to see a wide range of ideas and perspectives in every challenge that we face. Next on the horizon for Reform is refining our recycling parameters to make sure we can make really consistent and high quality filament. That will involve work from our process team, our recycling team, and our music and outreach team working together to make the best products that we can make. Reform will act as a springboard for education within the campus community and the Ames community into the plastic recycling process. We hope to allow students to have a hands-on experience with the recycling process and experience the challenges and the joys that can come with the recycling and having a finished product.